In this video, we'll be talking about dilations. In math, dilations are enlargements or reductions. For example, if I have a triangle, I can enlarge it by a scale factor, meaning multiply the sides by a number to make it bigger. So let's say if I multiply the sides of my original triangle by 2, it is going to be bigger. And if I multiply by 3, it's going to be even bigger, and the sides are going to be all multiplied by the same scale factor. The enlarged triangle and the original triangle are going to be similar. Similar means that all the angles are still congruent, but the side measures are multiplied by a scale factor. Let's say this triangle seems to be twice larger, so the side measures are multiplied by 2, so that means the scale factor used to enlarge the first triangle, the smaller one, to a bigger, is multiplying all the sides of the smaller triangle by 2 to get the sides of the bigger triangle. That is an enlargement. But dilation can work different ways. What if I have to reduce a triangle? If I have a bigger triangle and I am dividing by the same number, let's say if I divide all the sides of this triangle by 3, I'll have a smaller, similar triangle reduced by a scale factor of 1/3, meaning that the big triangle will shrink to 1/3 its size, so the scale factor will be 1/3. We'll talk about it a little bit more in detail as we go into our lesson. So first of all, in math, dilate, a new vocabulary word, means to enlarge or reduce the figure. So enlarge or reduce, shrink a figure. The center of dilation is going to be a point where we'll be dilating from, and that will be the connection of the vertices of pre-image and image. So to dilate, we need two things. First is the center of dilation. That center of dilation is the point on the coordinate plane that can be anywhere given by the problem. The scale factor is how many times bigger or smaller the figure should become. So the scale factor is needed to know if the figure needs to be enlarged or reduced. In other words, multiplied, magnified, or reduced, divided, or made smaller. So ABC here, triangle, is smaller. If I am enlarging it, I can multiply all the sides by 2, and 6 times 2 will be 12, 4 times 2 will be 8, and 8 times 2 will be 16. So if the pre-image is a smaller triangle, the image was multiplied by 2, meaning scale factor 2 was used. But if I go backwards and I say the image is smaller, so let's say from DEF, which is the bigger triangle, I'm trying to make a smaller triangle. So what that means is I am shrinking it. So if I'm shrinking it going backwards, it means I'm multiplying by a scale factor 1/2 or divide by 2. So scale factor is a number that you multiply by. Multiplying by 1/2 means division by 2. That said, in our dilations, if the scale factor is greater than 1, scale factor is labeled K. If the scale factor is greater than 1, the image will become greater. So K2 means enlarge 2 times. The image will enlarge 2 times. It means multiply the sides by 2. As a visual, I can say here is a triangle, and I need to enlarge it by 2. It means you multiply all the sides by 2. Or K3 means here's my pre-image, and I have to multiply all the sides by 3. That would be the image. So k equals 3. It means that the image will become 3 times bigger. The any scale factor bigger than 1 enlarges the sides of the figure, so that will be enlargement. Any number bigger than 1, that means 2.5. It can be fractional, it could be decimal, just bigger than 1. What if we multiply the sides of the figure by 1? Any number multiplied by 1 is the same thing. So the multiplicative identity says that if I multiply the sides of my triangle by 1, the figure remains the same. Anything times 1 is the same thing. So the scale factor 1 means that the image remains the same. And as an explanation, you can say if you multiply the sides of a figure by 1, the figure remains the same size. If the scale factor is smaller than 1 means fractionals, halves, thirds, 2/3, 3/5. It means that the image will become smaller. So any fraction is a division. Let's say half is division by 2. Multiplying by 0.5 is like multiplying by half. Multiplying by half means divide by 2. So the figure will be half the original size because fraction is division. Or 1/3, the size of the image will shrink to 1/3 of its size. So third means divide by 3. 3/4 or 75 hundredths, or image reduced to 75% or 3/4 of its original size. The image will reduce to 3/4 of the original size means that you're going to divide by 4, and then 3 parts of it will be the size of the figure. We'll see a few examples to see how to make dilations. Let's say I have to draw a dilation of a figure using center of dilation 6/2 and scale factor 2. First of all, the scale factor 2 means I have to multiply by 2. Scale factor is the number you multiply by in order to get some similar figure. So scale factor 2 means multiply by 2. It means that your figure has to be bigger. So this triangle, or the problem that you have, or an example that I have in my hands, times 2, larger image. How to draw the dilation from 6/2? So 6/2 has to be the center of dilation. Start with 0.62. So I'm going to record here the steps. Start at 0.62. From there, I'm going to connect every vertex and double the distance of unit count to get to the vertex. So I am going to connect 0.62 with each vertex and multiply the distance by 2, or double the distance. How does that look like? So from 6/2, I go to the vertex J. I'm not going diagonally, I'm using the unit count. So 1, 2 towards J, 1, 2, 3, 4. 2 by 4, I am going again the same distance. So that's going in twice, 2 by 4. 1, 2 by 4, 2, 2 by 4. And you can go again as many times as needed, but we only need to go 2 times. So 1, 2. That will be J prime. connect each vertex. So going to the next vertex, let's say I'm going to the vertex L, and I put the ruler to count the unit and double it, multiply by 2. So from 6, 2, going to the vertex L, I go 2 by 2, so I repeat that, 2 by 2, that will be my L prime. So from the center of dilation, I can draw those rays showing the connections. I have J doubled, 1, 2. I have the distance to L doubled, 1, 2. I have one more vertex K. So to go to K, again from the 6, 2, from 6, 2, I'm going towards K. 1, 2, 3, 4, 5, down 1. 1, 2, 3, 4, 5, down 1. So times 1 times 2. Okay, scale factor 2 means double the distance going to the vertex. 1, 2. That's where K prime was going to be. If I connect the new vertices, the enlarged triangle is my image, which is double the size of the original triangle. Let's see another example. In the directions it says draw a dilation of the figure using center of dilation 2, 2. So the center of dilation where the point of dilation is, and then scale factor 3. Scale factor 3 means multiply the size of each segment, JK, KL, and LJ, by 3. Scale factor 3 means the figure will be multiplied by 3. In other words, all the sides will be multiplied by 3. The dilation center 2, 2 is where the dilation begins. So we have to start with the point 2, 2. So start with point 2, 2. From that point, we're going to begin our dilation, which is connecting each vertex with the point 2, 2, and then extend the unit count 3 times. So we're going to connect each vertex with point 2, 2 and extend the unit count from there 3 times farther. So let's say I want to start with the vertex J. The vertex J is 2 units away from the center of dilation, so I need to extend that 3 times. 1, 2, 3. 1 is the distance to the vertex times 2 times 3. So here's where my J prime is. We are increasing the distance 3 times. 1, 2, 3. Going towards L and then extend. So from the center of dilation 2, 2, you have to notice the unit count 2 by 2 and extend it 3 times. 2 by 2, 2 by 2. This is where your L prime going to be. Connect the center of dilation to the vertex K. Notice the unit count 1 by 1. Go again 1 by 1 and go again 1 by 1. So the extension is 3 times. 1 time is to get to the vertex, then times 2, and then times 3. The new vertices are J prime, L prime, K prime, showing my enlarged triangle. The pre-image JLK was smaller. The image is 3 times larger. Another way that you can check the side measure, let's say KJ had the count 3 by 1, and it has to go 3 by 1, repeating 3 times along the image J prime, K prime. So that proves that this distance was multiplied by 3. So JK is repeating 3 times along the image. Same for KL. 1 by 3 repeats 1 by 3, 1 by 3, 1 by 3, 3 times along its image K prime, L prime. And then JL goes 1, 2, 3, 4 by 2, so it should work 4 by 2, 4 by 2, 4 by 2, 3 times along the image J prime, L prime. So that's another confirmation of proving that the enlarged shape is 3 times larger than the original shape. So let's see another example. Draw a dilation using scale factor of 3 again from the origin, and the scale factor of 3 means multiply by 3 from the origin, means you start at 0, 0. So I'm going to say here start at origin 0, 0, and then connect each vertex with 0, 0, and extend the unit count 3 times. So start at 0, 0, that's your center of dilation or point of dilation, and then connect each vertex with 0, 0 and extend the unit count 3 times. What that means is that from 0, 0, let's say I go to P, that's 1 square, extending it 3 times, that's 1 to get to P, times 2 times 3. That will be your P prime. So P prime is 3 units away now from the origin. From the origin to M, I have to go 1 by 3, so 1 to the right, 3 up. Then I have to extend that 1 by 3 1 time, that's just times 2. I need to have the scale factor 3, so 1 by 3, 3 times. 1, 2, 3. That's where your M prime will be. So from the origin to the vertex and extend. To, let's say, O, from the origin to O, I go 2 by 2, that's 1 time, 2 by 2, that's 2 times, 2 by 2, that'll be O prime, 3rd time. So from the origin to the vertex, times 2 times 3. You extend that distance. One more vertex to go to N. I count 2 by 3, and I extend 2 by 3, and I extend 2 by 3. So times 1 times 2 times 3. N prime has to be 3 times farther because of the scale factor 3. When you connect your vertices, the enlarged quadrilateral, is 3 times bigger. Let's emphasize that. Where the pre-image was enlarged by a scale factor of 3. Let's see a fractional example, or a scale factor still bigger than 1, but with a decimal. Let's say I have to dilate the triangle ABC from 0.31 with the dilation factor, or the scale factor, of 2.5. That means that my triangle has to be 2.5 times bigger. 2.5 means 2 times and a half. From the 0.31, so start at 0.31. Point 0.31 is right here, corresponding to the actual vertex C. Then if I connect each vertex with 3,1, if you connect C, the vertex C, with 3,1, how far is it from the center of dilation? It's 0 units away, right? So that is going to be corresponding to the same angle. Let's say if I have a triangle and I need to enlarge it from the angle, it means that the larger triangle will be overlapping with the same vertex that I'm going from. So that enlargement is going to be showing right overlapping that sharing vertex. So to connect each vertex with 3,1 and extend, the distance by multiplying two times and a half, or 2.5. So 2 times and a half time. So that is 2 full distances and half distance. That means that C remains as C prime because the distance from the center of dilation to C is nothing. Nothing times 2.5 is still there, so this didn't move. But to go to the vertex A, I'm going to have to count. So this is 2, and then I need to multiply it by 2.5. So that means 1, repeat 2, and here would be 3, but I don't need 3. I need to take half of that distance. That's where your A prime would be. For example, if I multiply 2.5 times 2, what I have is 5 units. So when you have this distance 2 times 2.5, the resulting number of units is 5. So it goes 1, 2, 3, 4, 5. If I was to look at this AC here, going once, going twice, and again 2 more units would be 3 times, but you don't want 3 times, you want half. So that's where the A prime would be. Same thing going from C to B. I have 4 units, and if I extend that 4 units twice, 4 more units will be 3 times, but I don't want 3 times, so I need to divide this in a half because I need the extension to be 1, 2, and not 3, but 2.5. That's where your B prime would be. C and C prime are in the same place. A prime now is 5 units away, and C prime B prime, since CB was 4 units, 2.5 times 4 is 10 units away. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the multiplication of the original pre-image times 2.5 gives you the enlarged image by the scale factor of 2.5. So the distance CA is doubled and then halfway, which is 1 square. Half of 2 is 1. And the distance of CB is doubled, and again half of 4 is 2. So that's 2 squares right here, times 2.5.